brought to you by Form Systems, the leader in API and cloud gateway technology.
So this is a slightly more technical talk. I think it's interesting, this entire conference, nobody's really said anything about time series. For relatively arbitrary reasons, when we started Datagami, the first thing we had was a time series library written in R. And we're in a co-working space, and there's a Bitcoin enthusiast. I think most co-working spaces have one. And he's building an app. He wasn't quite sure what. And he decided he's going to build a Bitcoin exchange, and he wanted to use forecasting as his point of difference. So he's used our API. So this is mostly a talk about Sunil's Mojo coin app with some Datagami explanation. I should say this is not a talk about Bitcoin, because actually I don't know that much about it. I read a few blog posts. I think Mark Andreessen made some good points about why it's significant, which I'll basically cover, but this is all cribbed from the Andreessen Horowitz blog, really. Basically, Bitcoin is secure digital transactions. There are lots of technical details, but it allows you to do some cool things. We have some friends working at a startup called 37 Coins, and they're doing remittances. At the moment, if you're from a poor country like the Philippines, a decent chunk of your population works in rich countries and sends money home. And people like Western Union banks charge really hefty fees to send Hong Kong dollars to Filipino pesos. And you can do it with Bitcoin for approximately zero, the non-zero part being the small fee that these guys charge. And the low cost is also interesting because you can work in units of 10 to the minus 8 of a Bitcoin. So you've got this sort of unique coin, which is somehow identifiable and I guess divisible, but you can use as a label. So one of the proposed uses of Bitcoin I haven't seen in action yet is spam. You could pay a 15th of a Bitcoin on an email to guarantee that it was legitimate. And somebody wasn't prepared, who hadn't paid, didn't transfer you that little bit of Bitcoin, you would reject their email. So this may yet happen. The other part of Bitcoin, which is, I think, maybe the more interesting one, it certainly hasn't had the press outside of the Valley, is the blockchain. So this is the ledger, the cryptographically robust record of all the transactions involving Bitcoin. And so that gets to some interesting things. OneName.io is either Big Brother's dream or something really useful. I haven't quite decided which, although I did sign up, so we'll see. You can link your personal identity verified through social media to your Bitcoin account, and then it's sort of what PayPal never got right. PayPal almost solved the online transaction problem, except you have this bit about how do you ID the people. And I guess they needed Facebook and Twitter to be around. So OneName.io doing this. There's been a lot of hype. Silk Road got busted. People declared the end of Bitcoin. We're a year down the track. It's still there. People are investing in new Bitcoin startups. I think it's worth paying attention. I should say that it's still early days, and if you want to move Bitcoin into, say, Turkish lira or Mexican currencies, liquid but not G8 currencies, you can take a couple of days to settle at a Bitcoin exchange. So maybe you're not going to get rich doing that. The price history of Bitcoin is interesting. If you plot it in US dollars, it was very cheap for a long time and then it blew up. What's actually going on is if you plot it on a log scale, you could see it was growing constantly with some kind of compounding up until the last year where it's leveled off a bit. The Bitcoin people, the people who are into Bitcoin, talk about these spikes in July 2011 and the beginning of 2013 as pump and dump. They seem quite open about the fact this market is being manipulated. The way Bitcoin is generated is you solve cryptographic, difficult mathematical problems numerically. So it's a mining concept. And in the early days of Bitcoin, I think the distribution of new coins is not uniform. So you'd get these rushes of people with new coins, and that would probably have something to do with it. But I also think there were people holding back on the coins and then manipulating the market. We've certainly seen this in FX markets, which are much bigger. We'll see later that we're actually interested in the last 6 months or so of Bitcoin pricing, where it's settled down a bit. If you zoom in, that's a reasonable, well, it's gone up by 50% and down again, so maybe the euro hasn't done that, but that's starting to look like something more stable than the earlier history. So I'll move on to the Mojo Coin app. This is our mate Sunil. I won't test fate by clicking on the link. I'll go to one I prepared earlier. This is his website. It's designed to run on Android. He promises he's making an Apple version, an iOS version, but he does actually, God, where is it? I closed it. That was smart. It does run on OS X. This is it connecting to the server and downloading prices. Yay, internet. So he's got these icons for Happy Cat. The price of Bitcoin is going up. He's using hourly prices. You can double tap for leap mode, and what that will give you is how the forecasts were. So it's currently 375, and the model suggests it's going to go 376, and then come down again to 375.5. So it's not going anywhere big in a hurry. It was, however, 372, and the model got that correct. Before that it was 371, and the model was wrong. The model was wrong. The model was correct. So you can see we're right more often than we're wrong on an entirely small and random sample. So this is pretty cute. You can have this in your pocket and check Bitcoin regularly and decide what to do. I think it's a neat example of the use of predictive APIs. It's a very simple app, and it just does one thing, and it does it quite well. I will now talk about... No, that's not. Now we'll talk a bit about how it works. You might ask, does it work? Can we really forecast Bitcoin? And so not that long ago, a month or so, these guys at MIT came out with it was all over the web. MIT forecast Bitcoin. It was fabulous. When you read the paper, they beat the crap out of this problem. If you read what they did, they took all the substrings of the price history of 3 different lengths, did Bayesian regression on the substrings, clustered them, and then used that as a predictor. That's an awful lot of computation. We, for reasons of ignorance, it never occurred to us to do something that complicated, just use Gaussian processes. Now, I don't know how many people... Who knows about Gaussian processes? Some people would have read a machine learning textbook. I see 3 hands. Yeah. Everyone learns regression, classification. Gaussian processes are neat. If you've got... Oh, wow, that didn't come out so well. So that's 3 data points on the YT plane, and you'll see why I need Z in a minute. You can put a little Gaussian around each data point. So you're building a model of a function that goes through the data points, and you want to somehow fit this to the data with something flexible, so why not suppose that every point is sampled from a normal, because they're everywhere. And the one thing you need for a normal is the width. You've already got the mean, so the only other parameter is the standard deviation. And then the trick with Gaussian processes is that you relate the width at each point in time to the distance between them in time with some functional form like this, which can be smooth or jagged or do whatever. It can be periodic. And so you can capture the structure of the data like this. If you want to see details, there's a really good book. It came out in about 2006. Has pretty much everything you need to know and is very well written. I encourage you to browse it. So to explain how, because it's an API conference, I thought I would show a demo of the API in action because I can't really show you the source code of the app. And that means going here. So the steps are, we can go to Quandl, which is a magnificent site for anybody who's interested in time series, and another very interesting model of providing an open source service and then providing premium services on top of it. So they now have curated data sets, premium data sets, which you can pay to get access to. The free stuff is pretty good. So we can take this data set, and maybe we only want the last 6 months. Looks a bit like the graph I had before. And you can download that to CSV. Through their very nice interface. We can find a... Oh, I've already got one there. That's fine. I'll open that in a text editor and just cut and paste. There are other ways of doing this. And now we've got a demo. This is not the Datagami product. This is a demo to show the steps of sending data to the cloud, building a model, and getting back the results. In fact, we're going to run about 40 models. I'm going to paste my CSV. And there's a trick here. We need our most recent observation to be last, and it's come in most recent observation first. So I'm going to have to invert the row order. I want the 24-hour average. Select the column, and I'm going to send it to the API. So this is a dot portrait of the last 180 points, and what we're doing is we've run up to about here or so, I'm not sure exactly, as a training set, and the last bit will be the out-of-sample test set. With time series, you can't really do cross-validation because the order of the observations matters, so your best bet is a sliding window approach. That was supposed to be in the cache because I'd run that earlier. I'm not quite sure what went wrong there. I'll do this. Aha! This was one I trained earlier using something more like an entire year's worth of data. And you can see what we've got is a bunch of models with different kernels. So I mentioned that covariance function. Let me do this. You can use different functional forms in the covariance to capture different aspects of the data. I don't know what you would say is the right structure for this. Financial time series are pretty famously difficult. Heteroscedastic, non-stationary. You can do some exploring by seeing what you get is, well, for example, you can fit a linear model. Probably not so accurate. People like Matern kernels because they give you non-differentiable paths. Arguably, financial prices, non-differentiable. It's okay, but if you look closely, basically forecasting a straight line up, and you're pretty confident that's not the right answer. Periodic can be nice because it really smooths it out. It's actually locally periodic. The only issue here is it appears to be missing some kind of y-axis trend. But it picks basically picks this turning point nicely and gets the right idea, so maybe you'd be happy using that as a directional forecast. The lowest out-of-sample error model is this one, which is pretty good. I don't know how clearly that shows up. You can see it on this screen better. The first out-of-sample point is definitely above the last in-sample point, and then it gets the next couple pretty well. However, that's the mean of the... I should say, one of the nice things about Gaussian processors, and the reason they actually can be very useful, is they give you a whole distribution. They don't just give you a point forecast. So here we've got the blue line is the mean of the forecast, and then the grey area is the 95% confidence interval around that because you have a whole distribution, because it's that kind of model. That's a pretty wide distribution. We're probably saying the next price, and these are daily prices, is, I don't know, 380 plus or minus 200. So you'd be wary about trusting this too far. That said, the means are consistently pretty reliable. So you choose your friends or your poison or whatever your metaphor is. And so the real question is, does it work? It's all anybody ever cares about in finance. The business world for predictive analytics can be a little more forgiving, but we get over some decent, like, back test over a year's worth of prices. The root mean square error is $2.50. Average price is around 400. Make of that what you will. The median absolute error is smaller because it's the kind of error measure that gives you smaller numbers. I think for something like a price series, the more meaningful measure of error is whether you get the direction right. If it's going up and you sell, you don't really care how close to the right price you were the next day. You went in the wrong direction. And we get 78%. Now, this tells you a couple of interesting things, because if we run the same model on the euro-US dollar exchange rate, for example, you don't get 78% accuracy. So I would argue that the Bitcoin exchange market is not as mature as the much larger and more liquid G7, G10 foreign exchange markets. And probably you don't have in Bitcoin yet the kind of aggressive high and medium frequency hedge fund activity that you see in foreign exchange. What you see with people is people buying and holding Bitcoin, doing some kind of fundamental trading based on where they think the sentiment of the market is going, in fact. These are the stories I've heard. But the really high-powered algorithmic trading or machine-generated execution isn't really happening yet, I think, as far as I know. That might explain why we get this working. And that is it.
Thanks a lot, Keiran.
Brought to you by Form Systems, the leader in API and cloud gateway technology.